On this part of chemistry, we are going to talk about alkenes, alkynes, and aromatic compounds, and just an idea about isomers. Okay, based on the previous video that we discussed, what are alkanes? And if you didn't watch that video is the basis of this video. So that means based on the previous video, you can understand this video, which is alkanes. And we said that in alkanes, we have to memorize 10 of them, which is methane, ethane, propane, butane, pentane till decane. So that means 10 ethanes, we have to memorize them, and you have to understand how many carbon atoms are there in each one and how many hydrogen atoms. Carbon atoms, how many and how many hydrogen atoms, and its general formula, and also how to name them. If you understand that one perfectly, this one will be easy for you to understand it. Okay. Mainly, we said we have alkanes, and you have alkynes, which is alkenes, and you have alkynes. And we said the general formula for each one here, it is CnH2n plus 2, and here it's just CnH2n, and here is CnH2n minus 2. That means here, and this one here, it means number of hydrogen atoms are twice number of what? Of carbon atoms. While here it is twice, but also 2 hydrogen atoms more than the double number. And here it's twice, but minus what? Minus 2. Okay, and we understand how to name in the previous video, understand how to name alkanes, and we gave examples. Today, and this part, we're going to understand alkenes and alkynes, and we're going to take what? Some examples. Okay, if we are talking about alkanes, for example, we're going to talk about what? Ethane. Then how it becomes what? Ethane, and how it becomes what? Ethyne. How it becomes what? Ethyne. Okay, so we know that ethane, it has 2 carbon atoms. So that means it is ethane, and we have here how many? 6 hydrogen atoms. Good. And these 6 hydrogen atoms that, as you see, they are here. Okay. All of them single bonds. So that means it is alkane and it is ethane. Good. What will happen now if I break these 2 bonds and I take these 2 hydrogens out, and these 2 bonds, I put them here as double bond. You see? This part here, I gave it here, and this part I gave it here. They become what? Double bond here. So that means what will happen? These ones will be erased. What will happen now? And what will be this one now? As you see, if I have 2 bonds, that means now this one becomes what? Ethene, E-N-E. It's what? Alkene. Alkene, it ends with E-N-E, and it represents double bonds. That means there is a double bond inside that compound. Now, this one now, since we have 2 carbon atoms, we call it Eth. And since we have double bond, we add what? E-N-E, ethene. Okay, same thing for other ones here. What about if we take, for example, here 4 carbon atoms. 4 carbon atoms, we know that it is what? Butane. Okay, as you see, each carbon atom, as we know, it has to have 4 bonds. Good. What will happen now if I break these 2 bonds, this bond, I break it and I make what? Double bond here. What will happen now? In this case, this one, what will be? It will be called, now, instead of butane, it's gonna be called what? Butene. Butene. It is called what? Butene. Butene, that means it has double bond. Good. It is alkene. Okay, but now we need to differentiate. Look, if we move back, this bond, it can be here, it can be here, it can be here, the double bond. So it has many places it can be. Okay, this one is butene. Okay, what about this one now? What about if we break these double bonds instead, these amino bonds, and we make here a double bond. what will happen now? It's still butene. So that means butene, whether the double bond is in this place or in this place or in this place, it's still what? Butene. But now, will the name be butene in all of them? Will it be butene in all of them? Butene with ENA? No, just we need to add, in this case, to differentiate between where the bond is, we need to mention the number of carbon atom that the double bond is on it. So we number these ones. You number them 1, 2, 3, 4. So as you go with naming them from left to right, so that means the first carbon atom that it has the double bond, this is the number of the carbon atom. So that means it is the first carbon atom here that it has what? The double bond. So you add here 2-butene. This is how to name it, 2-butene. Okay, you're gonna take also another example. If we have 1, 2, 3, 4, 5 carbon atoms, and as we know, each one will have 4 bonds, right? 4 bonds for each carbon atom, right? And here, as you see, each one has 4. Okay, now what will happen if I break this bond and this bond, and I make double bond here? So now I see these bonds now are erased, and instead of them we put here double bond. Now what will be this one called? Okay, to name it now, you need to count how many carbon atoms. 1, 2, 3, 4, 5. And what type was it? As you see, you have here double bond, so that means it is alkene. So 5, so that means it is pent. Then we add what? ENE, pentene. Okay, this is pentene. But pentene, I don't know where is the double bond. As you see, we have 5 carbon atoms, but we don't know where is the double bond. So that means we need to mention the place where the double bond is. So that means in this case, we need to number the carbon atoms. We have 2 types of numbering. We can number them 1, 2, 3, 4, 5, or we can number them from right to left by blue color here. 1, 2, 3, 4, 5. Good. In this case, when we number them, either from left to right to left, but the main idea is the double bond, it has to get the smallest number of atom possible. Okay, if we use now the green one, the green numbering here now, the first carbon atom in this one that it has double bond, we mention it. So that means this is now number 2 carbon atom. Okay, if we use the blue numbering here, the first atom that it has the double bond, we mentioned, as you see it is here. Good. Now, which one is the smallest number, 2 or 3? 2 of the green or 3 of the blue? 2 of the green is smaller. So that means we use this numbering now. We use this numbering since the double bond now, the carbon atom that it has, it will take the smaller number, which is 2. So we use this one. So right here, 2-pentene. 2-pentene. Okay, we're going to take now another example. We're going to take another example here. What about if I have 1, 2, 3, 4, 5, 6 here? Good. And I have here, but here as you know, here we have each carbon, it has 4 bonds. Good. Now what will we do now exactly? We will break this bond. We will break it and we make here double bond. So we'll break these ones. Then we put here what? We put here double bond. And also we'll make another thing. Same thing, we will eliminate these 2 hydrogens and we make here what? Double bond. Now what will be this one called? What will be this one what? Called? If I erase these ones, as you see, what will be this one now called? How can I name it? Okay, to name it first, you need to see, is it single bonds, all of them? It is alkane. Double bond, that means alkene. Triple, that means what? Alkyne. So we have here double bond and single. So that means single bond, we didn't count them, just we have double bond. Okay, that means this is alkene. Now, how many carbons? There are 6 carbons. So that means it is hexene. It is what? Hexene. Good, this is the first one. Hexene. Good. Now when it is hexene, put that in your mind, it is hexene. Now we need to mention where are the double bond. Where are they? Good. That means we need to number them. Number them now from right or from left. If we number them from the right, the first carbon atom here will be number 2. If we number from 1, 2, so that means the first carbon atom here that it will make the double bond, that it has the double bond, will be number 2. But if we number them from the left, this is 1, 2, as you see, that means number 1 will have the double bond. So we number them now from left to right. So this is 3, 4, 5, 6. Good. Now, where are the double bonds? We have 2 double bonds. Okay, where are they? We have number 1 and number 4, because we mentioned the first carbon atom in our ordinary that has the double bond. So that means we have 1, then comma, 4, then as you see here, 1, 4 hexene. But look, if we have 2 double bonds, as you see, have double bond here and double bond here. If we have 2, we have to add the prefix what? Di. Di to represent what we have 2. We put here the di now. So where to put now the di? We have to add the prefix di, but where to put it? Okay, to put the di, you need to remember that we put it exactly between the E and A. Before the A and A. So that means what will be the name now? It will be 1 and 4 hexa. Then you add here what? You add di. Hexa, and you add A here. So that means it's going to be 1, 4 hexa diene. Diene means 2-ene. That means 2 double bonds, 2 pair of bonds. And I hope that is what? Clear. So this is now we understand how to name alkenes. How to name alkenes. What about if we have three of them, 3 pairs of double bonds, 3 double bonds? In this case, we add the word tri. Tri, you put it before what? Before ene. Okay, now we go to cycloalkene. Cycloalkene. As we know, if we have 1, 2, 3, 4, it can be this way, it can be this way. What do we call this one now? As we know, if it is single bonds, it is what? Butane. This is now butane because it has now 4 corners. That means 4 what? 4 carbon atoms. Good. Now, in each corner, we have carbon atom, and this carbon atom, it has also 2 more bonds to make what? Hydrogens. That means here we have 4 carbon atoms and 8 hydrogens. And this one is cycloalkane. This one is cycloalkane. So cyclobutane. Okay, what will happen now if I break these 2 bonds and I make here, that means I eliminate 2 hydrogens and I make 1 double bond here. In this case now, this one will not be cycloalkane. It will be cycloalkene. So what will be called now? Instead of this one, we add what? A and E. So that means it is cyclobutene. Cyclobutene. Same thing if I have here 1, 2, 3, 4, 5. So as you see now, what is this one called here? We have 4. How many corners here? 5. So that means it is pentane. Pentane, it is single bonds. Okay, what about if I add 1 bond here, double bond? So that means this case now, it's gonna be, instead of pentane, it's gonna be what? Pentene. It's gonna be pentene. Pentene, but now it is closed shape because add here what? Cyclo. So it is cyclopentene. Cyclopentene. Okay, what about if I add now on cyclopentene, if I add here, for example, bromo, I add what? Bromine. What will be this called now? In this case now, we need to number the carbon atoms. And when we number the carbon atoms, we number them where the double bond takes the smallest possible. So that means if I can number them here 1 and here is 2, 3, 4, 5. No, because now if you move this way, when numbering 1, 2, that means you are not including now the double bond. So that means when you go in the sequence of numbering, the double bond has to go in your what? In your way. So that means in this case, I number them here. As you see, here will be number 1 and here's then 2. Look, I'm moving this way of numbering. So here's 3 and here's 4 and here's 5. Now, as you see, when I go from 1 to 2, the double bond will be there. The double bond will be there. So that means it is on number 1. So in this case now, I go to see this addition, system 0, which is bromo. So I add here bromo, but bromo is on number what? On 3. So you say 3 bromocyclopentane. So that means it's going to be called now this one 3 bromocyclopentane. And you hope that is what? Clear how to name now. We understand how to name alkenes and how to name cycloalkanes. Okay, what about now alkynes and cycloalkynes? If I have now C, now we are talking about alkynes. Alkynes. Okay, if I have C, this one here, and as you see here, these ones, all of them single bonds, this is one is called what? This one is called, as we know, ethane. Ethane, and it is alkane. Okay, what will happen now if I eliminate these two hydrogens and I make double bond here? And also I eliminate these two hydrogens and I make here another bond. And then as you see, I erase these ones. They are no longer there. What will happen now? That means this is now what is left, and this bond, it means there is hydrogen here, and this bond, it means there is hydrogen here. So it can be written this way, or it can be this way: HC3 bonds, then what? Triple bonds, then it can be this way or this way, both of them right. Okay, in this case now, this one will still called ethane, alkane. No, since it has 3 bonds, which is triple bonds, that means its end has to be Y and E. So that means this one, instead of E and E, this one will be called what? Ethyne. So that means it's going to be what? Ethyne with Y and E instead of what? Instead of A and E. So this one is still called what? Alkyne. Alkyne, that means it has triple bonds. And you understand now, its name will be with Y and E: alkyne, methine, ethyne, propyne, butane, so on. Okay, now same thing if I have like C 1, 2, 3, 4, 5. In this case, if we have this one as, and these bonds, as you know, it means hydrogen. It means what? 4 hydrogens. Now what will happen if I do the following? What will happen if I break these, or if I eliminate these 2 hydrogens? I make 1 bond here, and I eliminate these ones and I make what? 1 bond here. Okay, what will be then this one called? What will be this one called? What it will be called then? As you see, to call it now, it is, since it has triple bonds, so that means it is what? Y and A. How many carbon atoms here now? 5. So that means it is pentine. Good. Y and A, pentine. Good. When it is pentine now, maybe the double bond is here. Maybe the triple bond is here or here or here. I'm not sure where is it. So that means when I tell you pentine, you will not understand exactly where is the double bond, where is the triple bond. So in this case, when you mention pentine, you need to mention the number of the carbon atom that the triple bond is on. So now we need to number them. We can number them from 1, 2, 3, 4, 5, right? Or we can number them by blue here: 1, 2, 3, 4, 5. Which one is right numbering? The one that it has a triple bond on the least number. So this one here now, which is the yellow, as you see, the triple bond is on number 2. While the blue, if you go, you're going to see that the triple bond is number what? On number 3. So we choose the yellow numbering. Then we say what? It is 2-pentine. 2-pentine. This is how to name what? Alkynes. And I hope that is clear. Okay, related to cycloalkynes. If I have here this one now, as we know, since it has 4 corners and all of them single, so this one is called what? Butane, but what? Cyclo. So this one is what? Cyclobutane. Okay, as we know, what's there? There is here in each corner, there is what? As we know, still 2 bonds for hydrogens. Now, if I break these 2 bonds and I make 1 bond here, and also I eliminate these 2 hydrogens and I add triple bond here. Now, what will be this one called? Since we have 3 bonds here, so that means it is YNA. So that means it's going to be called what? Butane, but here what is cyclo? So that means it's going to be called what? Cyclobutane. Okay, what will happen now if I add one substituent group here? For example, add what? Bromo. In this case, what should I add here for this name? I should number them now. I need to number the carbon atoms. So the carbon atoms, I need them now to number them. 1 from here. So here is 2, and here's what? 3. So that means where is bromo on number 3? So that means it's going to be 3 bromo. So it's going to be like this. 3 bromo cyclobutane. When I number them as a cyclo shapes, that means we need to understand that the 3 bonds take the smallest number possible. So these 3, we number them this way, and I hope that is clear. So you understand now how to name alkenes, how to name alkyne, cycloalkenes, and how to name alkynes and cycloalkynes. Okay, we still have now 2 points, which is aromatic compounds and just isomers. Isomers, just we're going to take a brief idea about them. Isomers means if I have 2 compounds, they have the same number of hydrogen, the same number of atoms, whatever they are, hydrogen, carbon, same number of atoms for each element, but they have different what shapes, but they have the same number, the same what number. Okay, just we can take example here. We can take example here for isomers. If I have C 1, 2, 3, 4, and here we have, as you see, on each carbon atom we have 4 bonds. Okay, how many now? How many carbon atoms here? We have 4 carbon atoms. Good. And how many hydrogen atoms? As you see, if you count them, 3, 4, 5, 6, 7, 8. Or as long as it is single, that means H, it has to be twice plus 2. So 4 times 2 is going to be 8, and here what? 10. We can, as you see, they are what? 10. Good. What will happen now? What will happen now if I do the following? Pay attention. If I take this one here, this part, I take it and I put it here. I put it here. You see, C with what? With 3 bonds. Good. And this hydrogen now that it was here, I put it instead of this one. So that means instead of this one now, they'll be hydrogen. And this one will be here. In this case, what did I do? Just I have taken that carbon atom from here with its 3 hydrogens and I put it here. I put it what? Here. And I took the hydrogen that it was here and I changed it to be what? This place. What will I get? This thing, what will I get? Exactly this one. As you see, this is now what will I get? Where the H is what? Where the H is here. Where the H is here. Now, what's the difference between this one and the previous one? Number of carbons, of carbon atoms and hydrogen atoms is still the same, which is C4 and H10. But now the structure is different. The arrangement of atoms is different. So these 2 compounds, now we call them what? Isomers. So isomers, they have the same molecular formula. Same molecular formula, that means same number of atoms for each element, but they have different what? Structures. In this case, we call them what? Isomers. And we have 4 types of isomers. We have a structural isomer, and it is the same like we already did. And we have stereoisomers, and we have number 3, which is optical isomers, and you have what? Geometric isomers. Optical isomers, they have the same structure, but they have different order on the what? For example, if I have here now a central atom here, and I have 4 functional groups here, like these ones, 4 functional groups. And these 4 functional groups that attach, if they change their places, this one here was a square, then the square becomes here, and the triangle becomes here, for example. And these ones, in this case, we call it what? Optical isomers, where they are the same, but they have what? Different places as spatial places. And these optical, we have 2 famous of them, which is called alanine and also what? L-alanine. We need to memorize them. These ones are 2 types of what? of optical, and you understand what is the optical. Related to geometric, geometric is like we have trans and what, and cis. We have what, trans and what, and cis. This is for what? This is for geometric what, isomers. Geometric isomers, that means if we have the same here double bond, and you have one main functions here, substituents here, but I can change their places to be, instead of being here up, I can change them then to be one in this part and one on this what, on this part. So instead of being on the same side here up, we can change them one here and one here. In this case, we call them what? This is trans and this is cis. It depends. They have the same carbon number of carbon atoms, same number of other elements atom, but their places for this addition, the groups they are attached is what, in different places. This type of isomers, we call it what? We call it geometric isomers. Okay, we need to remember in isomers we have 4 types of isomers: structural, and we understand what how is it. And we have, we take a first example, and we have optical, and we said it's D-alanine and L-alanine as part of it, as an example. And we have geometric and trans and cis related to geometric, keep that in mind. And we have what? Stereo. Okay. And in some types we can classify, in some parts we can classify geometric and optical as stereotypes. So if the questions come related to these ones, usually rarely it comes questions from isomers, but if it comes, as I said, D-alanine and cis and trans, and as you have 2 or 3 examples, all questions similar, you have them on the quiz. On the quiz, you have them as part of the questions. Okay, we move now to the final part of our topic today, which is aromatic compounds. What are aromatic? Aromatic, if you have, as you see, if we have this one here, 1, 2, 3, 4, 5, here we have, get 6. We know that in each corner there is what? Carbon atom. In each one, carbon atom. And carbon atom, it has 4 bonds. So these ones already 2, and that means it has 2 more carbon atoms. You get 2 more carbon atoms. Okay, this one is called what? Cyclohexane. All of them single. Okay, what would happen now if I make these 2 as 1 bond, and I make these ones as 1 bond, and I make these ones as what? As 1 bond. So that means I have taken from each double bond, I have taken out 2 hydrogens out. So that means what is left now? It was C6 and H what? H12. Good. I have taken now 2 and 2 and 2, so I have taken 6 hydrogens. So what will be left then? It's gonna be C6 and H what? H6. And this one now is what? Is this shape. It has 6 carbon atoms, 6 corners, and it has 6 hydrogen, because it has what? In each place we still have just what? 1 hydrogen, which is the outer parts. These parts is still there, which is here. As you see, these ones are still hydrogen, 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 hydrogen. Just we used the inner bonds, the outer bonds, the external bonds. So this one now is called benzene. This one is called what? Benzene. And this benzene now, these, as you see, we call them alternative bonds. As you see, we look here at the sequence: 1 bond, 1 double bond, then single bond, double, single, double, single, double, single, double, single. So that means these bonds now, since they are double, single, they will not be in their place. They can change their places. This one now is the double, and here's the single. Then they can change. Here will be the double, then here will be the single. Then they keep rotating in this way case. So instead of this one here now, we draw a circle instead of these ones, like inside. We draw a circle, like it shows their movement inside it. So that means we'll get, as you see, this shape that it has here, 6 corners, and inside it what? A circle. And this one is called what? Benzene. This one is called what? Benzene. So aromatic compounds, it has the main product is benzene, and there is what? Other attached what? molecules here. So that means in this case we call it what? Aromatic. Okay, so aromatic mainly they contain what? Benzene ring. We call this one now benzene ring, where it has hexagon and inside it what? A circle. Keep that in mind. Good. Now how can we name these aromatic compounds? If I have now, as you see, this one is the main one here. This one is the main one, and it has, as you see, 6 carbon atoms, and inside it a circle. Now, if I add here CH3, what will be this one now called? Good. What will be called now? We go to the main one. What is the main one here? It is benzene, right? What is this one now? It is called what? Methyl. It is called what? Methyl. It is called methyl. Okay, this one now, what do we call this one now? Methyl, we start by the additional here, the attached compound, then to what? To the main one, which is benzene. So this one is called what? Methyl what? Methyl benzene. Methyl benzene. Okay, what about if I change instead of methyl here, I add CH2CH3. This one is called now what? It's called ethyl. It is called what? Ethyl. So if it is ethyl, instead of methyl, you write what? Ethyl benzene. Ethyl what? Benzene. So just you name the one, the additional here, then you go to the main one, which is what? Benzene. Okay, what about if I have two attached groups, like this is here. How is it here? Then this is now the circle. Then we have here, for example, here bromo, and here is for example here methyl, which is what? CH3. What do I name this one now? In this case, if I have two attached groups, in this case I need to use the numbering now. Here now I number it, for example, 1, 2, 3. Good. And I have here methyl, and I have what here? Bromo. Okay, I start by B bromo, then bromo is number 3, so you can call it now 3 bromo, then methyl. So that means it can be 3 bromo, then what? Methyl benzene. Methyl what? Benzene. Methyl benzene. It can be named this way. Okay, what about if I have here CH3, for example, and here is CH3, and here is CH3. How do I name these ones? How do I name these ones? How many CH3 we have? As you see, we have how many of them? We have 3. So that means we have trimethyl. We have what? Tri, and all of them methyl. So that means we have tri what? Methyl. Trimethyl for what? For benzene, which is the main one. Benzene. Good. Now we need to mention their numbers. Where we take what? The smaller numbers possible. We can number them like 1, 2, 3, what? 4. So let me see, you get now on 1, and on 2, and on what? And on 4. So that means they can be called what? 1, 2, 4, trimethyl benzene. I hope that is clear. Now we understand how to name compounds that are related to alkene and cycloalkene, alkyne and cycloalkyne. We have taken an idea about isomers, and we understand now about what? Aromatic compounds. Thank you. See you in other videos.